Welcome to episode 36, Comparing Azure Storage Types and Tiers, where we line up the storage options side by side and talk plainly about fit. Azure offers several services that all hold data, yet they are built for different shapes of access, durability expectations, and cost rhythms. When you compare them directly, strengths become obvious and trade-offs stop being mysterious. A good comparison starts with questions. How big are the objects? How often are they read? Who writes them? And how strict is the latency budget? From there, you can map each requirement to a specific capability rather than guessing. A small scenario helps. A product team needs images, logs, user settings, and backlog jobs. Each of those favors a distinct service. By matching pattern to platform, you get performance without overspend and control without complexity. Azure Files provides server message block shares that look like network drives to servers and desktops, which makes lift and shift realistic. Legacy applications that expect a mapped drive or shared path can keep running while you modernize around them. Under the hood, it is still cloud storage, so you gain snapshots, redundancy options, and predictable capacity management. Typical fits include user profiles, shared content repositories, and app configuration directories. A misconception is assuming file shares solve every compatibility gap. Permissions, path lengths, and latency still matter. Practical steps include setting consistent naming, using identity integration for access, and right-sizing performance tiers for peak periods like login storms. When you respect those constraints, Azure Files turns stubborn dependencies into manageable services. Queues exist to decouple producers and consumers by passing small, durable messages that signal work to do. They let a front end acknowledge a user quickly while background workers process tasks at their own pace. This pattern stabilizes systems under bursty load and adds resilience when downstream services have variable capacity. A classic example is an image upload that enqueues a resize job rather than blocking the request. A misconception is using queues as long-term storage. They are mailboxes, not archives. Keep messages small, include item-potent identifiers, and set retry and poison handling so bad items cannot clog the lane. Done well, queues make asynchronous behavior predictable and throughput smooth. Tables provide schemaless key-value storage for fast lookups where rigid relational models would slow development. Each entity stores flexible properties, and access patterns favor partition keys and row keys for efficient reads. Tables shine when you need inexpensive, wide scalability for metadata, session state, feature flags, or sparse records. A misconception is treating tables like a relational database. Cross-entity joins and complex queries are not the goal. Success comes from designing keys that match read paths and keeping properties modest in size. Add secondary indexes only when necessary, and consider combining tables with blobs when records need attached large objects. This mindset keeps tables nimble and cost-effective. Data Lake Generation 2 blends blob scalability with a hierarchical namespace, adding directories and permissions that feel natural to analytics teams. The hierarchical namespace reduces rename and delete costs for large trees and enables fine-grained access control for pipelines. Typical patterns include batch ingest, curated zones, and downstream machine learning that benefits from organized folders. A misconception is thinking a lake is just a big bucket. Its value comes from structure that mirrors how teams analyze data. Practical steps include defining zones, versioning datasets with time-stamped paths, and enforcing conventions through pipelines. With intentional layout, the lake becomes a collaborative surface rather than a dumping ground. Access tiers, hot, cool, and archive let you align storage price with how often you read the data. Hot is for frequent access with low latency expectations, cool reduces cost for occasional reads, and archive compresses cost for rarely touched datasets with slow rehydration. The trick is timing. Move data as its value curve changes, not months after the bill spikes. A misconception is that archive is a perfect backup replacement. Retrieval times and early deletion fees still apply. Use lifecycle policies tied to age, tags, or events to automate transitions. When tiers mirror reality, your bill becomes a reflection of value rather than a penalty for growth. Performance tiers, standard and premium, answer the latency and input and output operations per second question before it becomes a user complaint. Standard media serves most workloads well, while premium solid-state options suit hot paths like profile containers, stateful caches, or metadata catalogs. The goal is targeted speed where it matters, not blanket upgrades that quietly burn budget. A misconception is that premium always fixes slowness. Bottlenecks may be network, design, or query patterns. Measure first, place only critical folders or containers on premium, and revisit after changes. Performance tiers are steering wheels, not magic switches, and careful placement keeps both speed and cost sensible. Workload patterns map cleanly to types when you name the access shape honestly. Large, immutable files favor blob storage with block blobs. Append-only logs fit append blobs. Disk-like random access prefers page blobs behind virtual machine disks. Shared legacy paths call for Azure files. Asynchronous workflows crave queues. Sparse metadata lands in tables. And analytical estates use data lake generation 2. A misconception is forcing a single service to do everything for operational simplicity. That usually increases cost or reduces reliability later. Document the pattern for each data class and choose the default service accordingly. With that discipline, teams stop arguing preferences and start shipping predictable designs. Costs come from more than gigabytes at rest. They include transactions, egress, and redundancy choices. Many tiny operations can outweigh storage price, and cross-region reads or internet egress can surprise teams who only budgeted capacity. Redundancy adds resilience, but also replicates costs in line with protection level. A misconception is that the cheapest per gigabyte tier always wins. Slow retrieval or minimum retention can erase the savings. Model realistic access, batch operations to reduce chatter, cache where feasible, and keep data close to compute. Clarity on cost mechanics turns pricing from a guessing game into a plan you can defend.
Lifecycle management policies keep storage tidy by moving, versioning, and expiring data automatically. Set rules that cool objects after a defined age, archive them when their read rate drops, and delete them when compliance windows close. The benefit is compounding: fewer hot bytes, fewer stale versions, and simpler restores. A misconception is treating lifecycle like a one-and-done setting. New products and regulations will change the targets. Review policies quarterly, tag data by purpose, and test restores from each tier so recovery remains practical. Automation here converts discipline into default behavior.
Security rests on defense in depth, encryption, keys, and private access. Encryption at rest is table stakes. Identity-based access and time-bound tokens move you from broad secrets to least privilege. Private endpoints and restricted networks close exposure paths, while logging gives you proof. A misconception is that a single strong control covers gaps elsewhere. Durable security layers work together and assume mistakes happen. Prefer managed identities over embedded keys. Scope shared access signatures tightly and enforce private connectivity for sensitive accounts. With those habits, storage behaves like a vault rather than a closet. A decision matrix helps teams choose without debate. First, describe the data shape and access pattern. Then, pick the service that fits that pattern best. Next, choose redundancy and performance based on recovery and latency goals, not on fashion. Then, select access and network controls that match risk, followed by lifecycle rules that match retention. Finally, review cost against actual usage and adjust tiers. The matrix is not bureaucracy. It is a shared language that prevents drift and anchors decisions in intent. When everyone uses the same map, choices become faster and more consistent. Practical selection guidance is simple to remember and powerful to apply. Use blob storage for objects, files for shared paths, queues for decoupling, tables for sparse metadata, and data lake generation 2 for analytical estates. Add hot, cool, or archive based on real read patterns and place premium only under measured pain. Wrap everything with identity-based access and private connectivity. Then automate lifecycle so data ages gracefully. Watch transactions and egress, not just capacity, and keep decisions written down so the next team repeats success. With this mindset, storage choices stop being debates and start being quiet enablers of reliable, efficient cloud systems.